Hello builders, my name is G. You've asked for it and I'm delivering here. An upgrade to our tRPC Turborepo walkthrough where I'm going to be focusing on NeonDB and how we can use databases within a Turborepo's monorepo. And a monorepo means that there are multiple apps sharing particular code. And in this case, database infrastructure. We're using NeonDB, a serverless cloud infrastructure offering databases as we need them. In this case, let's demonstrate what we can do. So here in our notes app, in app 1, we're going to just say hello from app 1. This is a note. And then we'll hit create note here. And you'll see that the note appears here. And to prove that it isn't stored in state, we're going to hit refresh here, and it's persistent. It's stored on our database. Now here on this other side, we have incidents, right? We're going to say help from app 2. And we're going to make it a high severity incident. We're going to hit report incident. It pops up near immediately. If I hit refresh, it's still there. If I hit investigate, we're investigating it now. Hit refresh. It's now updating in the investigating column. It's still there. Let's say I've resolved it. I'm paying attention to app 2. We can delete it. No incidents reported. If I refresh, we're in a refresh state here. Nothing in there. If we scroll down here, we can see that both apps have a shared announcements panel. So let's just say here, help needed in app 2. Please, app 1, help. If I post this announcement and refresh on app 1 and scroll down, we can see that message now appears in app 1, even though they're on separate URLs because they're tapping into the same database. Now let's just say here, hello from app 1. Write in the comments down below your walkthrough ideas and I'll build them. Subscribe and like the video, please. And if I post this announcement and hit refresh and scroll all the way down, we can see that there. Please do it. And so hopefully you can see some useful things that we're going to be implementing in this walkthrough. Let's jump over to the code and make these demos. Okay, so we're starting this walkthrough here on the Neon console. Usually I start it in the terminal, but we're going to need to be creating 3 databases for our project. And the reason that we have 3, if you remember from the demo, we're going to need 1 for each one of our apps. So that's 2 of them. And to demonstrate that in our Turborepo, each app can have an independent database that it taps into. And then the third database shows that 2 applications within a Turborepo monorepo, that's a mouthful, can access and tap into safely the same database. And we're going to be using Neon here to get a serverless Postgres database. And in case you're not familiar, right, serverless means that we don't have to manage our own server. We don't have to, create a database in the cloud and then connect to it. Neon's already dealt with it for us with some managed defaults. And so for us, all we need to do is create a new project here, gain access to our database via an API, and be able to tap into a ready-made database for us. We don't have to configure anything. We don't have to manage anything, right? They have some defaults here, and they'll manage the database on our behalf. And so here, if you're creating a Neon account from scratch, you might hit some onboarding things before you get to this screen. But once you hit this screen, we're just going to name this one app 1DB. And we're just going to do the same across all 3, app 2 and app 3. So right now we'll just create an account. You'll be taken to this dashboard. To create the next one, you're just going to click up to whatever name that you provided here and hit the free. If you're on the free tier, you're going to generate a new one. We're going to have app 2DB, right? We're going to create that. And then we're going to create the third one, app 3, shared app DB, and this is going to be the shared one between all of them. Great. And the thing that you're going to really want to pay attention to, if you hit connect here, you're going to see a connection string, and you're going to hit copy snippet. So the next step that we're going to be doing after this is creating our .environment.local to be able to register all of our various different database URLs. And so you're going to hit copy snippet, and we're going to do it across all of our different applications, right? App 2, App 1 DB, right? We're all going to go back to each one of these databases or dashboards, hit the connect button, and then hit copy snippet to be able to pull it. And make sure that you have the unique one for each one of those when we get over to the .environment.local. So without further ado, let's jump back over to VS Code and look back at our existing code base from the tRPC TanStack walkthrough, which again, if you haven't seen that, link will be in the description. Watch that one if you want to know how we got to it. It's a pretty straightforward website, and so I don't expect for most people to struggle with it, but if you wanted to just gain some context, understand tRPC TanStack when used with Turborepo, check out that one, then come back and knock this one out. So we're here in VS Code now, and I've written out a .environment.example here, and I'm going to have to eat crow because I forgot a step in the previous one, or at least to show you. So here you can see that the first database URL here, it basically says Postgres. This is the private password. If you remember here, right, the password is hidden. So that's why this is just what is being replaced here. And there's a difference between pooled URLs here, right? You'll see -pooler. And if you see down here, there's pooler right here. And we're just going to refresh the password here. Ha ha ha. You can't steal it. Whoops. Let's hide it first and then reset. There we go. And that's how you can reset the password in case you accidentally leak it. You can turn off pooling here, and that's for the second option down here. So when we do a migration, right, when we use Drizzle Kit to let me take a couple steps back here. When we create a schema that we want to push up to our database, right? When we come up with the shape in which we want our database to look like, we need to both generate and then push it up to Neon so that Neon knows what the database needs to look like. And we're going to be using Drizzle Kit for that. We want to use a direct URL, as stated here. We want to avoid the pooler/sessions caveat during session changes. But when we're using the apps through the API and we want to do any of our CRUD operations, then we want to use Neon pooled URLs for serverless or highly concurrent app traffic, right? So when we have multiple different applications tapping into the same database, and by extension users as well trying to tap into the same Neon URLs, we want to use the pooled URLs, right? And so the top ones have this radio button be selected here for the pooler one, and then for the migration URLs down here, you just click it off, right, and use the direct URL. So I'm going to go and do this real quick for environment.local, right? So you would just do .env.local and make sure that you type correctly and have no misspellings each of these database URLs, right? And so I'm just going to be replacing all of these, and we'll be right back with the next step of this walkthrough. But again, please make sure that you write these out correctly, and then when you paste it, make sure that it's the right app, right, for each of these database URLs, or else you're going to get awfully confused. And then obviously the shared one, just put it in the shared URL. Awesome. On to the next step. Oh, and one quick note, in case you were wondering whether or not you can have quotes or no quotes, it doesn't matter. You can use them with or without. Just by, what I have here, you can use the quotes by just, pasting it in here, or if you just want to replace it, totally cool. The quotes are optional. So anyways, now actually on to the next step. So step 2, we're going to be setting up our directories here to hold all of our 3 databases. So first thing we're going to do is add a folder here. Make sure you add it to packages. You don't accidentally add it to tRPC. We're going to be adding in the DB directory here. And inside of here, we're going to add another folder called source, right? So if you notice the pattern here, we have packages, we have the name of the package, and then we have source on the inside. What we're going to be doing in a little bit is adding our package.json, but we're going to be adding it at the DB level, not inside of source. And source will be where we have our source code related to the database. So just make sure that you're very careful in keeping this particular structure that I'm creating. Inside of source, we're going to split things further to each of the individual directories. So we have app1, then we're going to go do source again, app2, and then the last one here, shared. Great. So make sure that this is the structure that you have for the directories. And then inside of DB, we're going to be creating package.json. Now I'm going to paste in our package.json here, our contents of it real quick. Some things to note that are important. Name of the package. It's important that it's at repo/db. These are NPM package related things, so we don't really need to worry about it for this project in particular. There's no reason to be publishing this, so that's why we set private to be true. If set to true, then NPM will refuse to publish it. So it doesn't go on the NPM package registry so that anybody who, anybody can install it basically, and we obviously don't want that, and the version is related to that, so you can bump it up, bump it down. For private packages, typically you would could do this if you were like shipping change logs, then you would bump up the version to coincide with canonical changes to package.json to these individual packages, but that's up to your internal convention. The export's extremely important. If we want to be able to import things inside of the apps of our monorepo and be able to access the different things that are inside of our database package here and our tRPC package, it also has this export field here. We have 4 of them being specified here, dot being the root. And so, if we were to just create real quick, right, import foo, right, and if we were just looking at the dot here, right, if we do from at repo/db, right, we would have access to everything that is in source/index.ts. Now, we haven't created it yet. You can see here in tRPC, we would have an index.ts. So this same export that you can see inside of the tRPC package.json allows for us to do this type of import from our apps directories up here, right? Now, what would be the corresponding one for this one? And let me just comment this out real quick so we don't get too many of the squigglies. No, we'll remove that in a second, right? This would be, import, foo, right? Or food from at repo/db/app-1/schema, right? So this package name that we specified up here would just replace the dot, right? Specifying that that's the root. And we're just basically saying for this particular package, right, we're going to be grabbing stuff from it. And, if we don't specify anything after this, right, if we don't specify anything here, then we just mean the stuff that's in index.ts. If we're specifying, right, in this case, app1, the directory, and a future file, schema.ts here, right, we are making that export explicit, right, so that app directories, our apps here, can import from them, right? And, remember that we put them into a source directory here, so we have to include source in our path here. So cool. Export's incredibly important. A lot of people mess up and get really weird errors because they forget to export things. So please remember to export the stuff that you need. So one thing you're going to notice me do here is actually remove the generate portion. We don't actually need it since we have push. Generate is a alternative way of pushing because you would do two separate commands here. You would generate and then you would migrate up. Now we're going to be just managing, actually just getting things up to deploy. And so really you only need push for that. You would use generate and migrate to do kind of very granular SQL migrations. Like let's say you have data already, user data already existing in the database in the cloud. You don't want to mess with that. So you need to provide careful mutation instructions. And so we don't need that obviously for this walkthrough, so it's a little bit out of scope. So I'm just going to remove that. Instead, we're going to be focusing on these 4 scripts, commands that we have that are really aliases. As you can see, we have, just like we did with the exports here, we have a longer form piece here. You could technically write pnpm, run, drizzle kit, all of this stuff, right? This is just shorthand notation that we've created to be able to do pnpm, run, all of these different things. So starting from the top here, we just have type check, right? Which is running the compilation step and running the TypeScript compiler. That way you can surface any errors that you might have from compilation. So not at runtime. Runtime things require you actually to be in the actual website, clicking through things, and that would trigger runtime errors. This is to type check anything that might happen at compilation. So, I don't know. There are so many different types of errors. I can't think of a single one, right? Or we just hit one earlier, right? There are no trailing commas in JSON. This would trigger a compilation error in this compilation step here, right? Because this is not an error that would surface at runtime. It is something that would be checked and surfaced as an error at the compilation step, at build, basically. And this type check is going to be checking across our apps, our packages, and our databases. All of them have, the type check command here. And so long as it has this, it's going to be run as well, right? So you can run it across any of the different surfaces, any of the different packages. So you can go into tRPC, run type check to check for any errors. When you go into the apps here, right, I believe API is one that has the type check as well. I don't know if these ones have it. Let's see here. They do. So yeah, you can go into any of these individual directories, run a type check to make sure that you don't run into any compilation errors, and you can fix it right away. Because you know that when you run pnpm run build, it automatically does this compilation check. And, you'd rather fix all of the issues here before you push it up to Vercel or AWS, run an error there, then you have to fix it, push on GitHub, trigger, CI/CD pipeline. That can be, time expensive, cost expensive. So instead, it would be better to just check it on your local machine for any compilation errors, and that's what the type check command allows for. We have our push here, right? Just think of it analogous to a GitHub push, right? We have a configured in a second this drizzle.app1.config.ts. We'll have one for each one of these where we'll configure our database URL, basically point to it. And you're going to see later on, we have a package here that we're depending on, .environment, which loads the environment variables so that we're going to be able to retrieve that database URL in our config here and then push, right? And following the rules of our what's going to be in our config.json, we're going to be able to push the schema that we've created in this database package here and basically allow for NeonDB to adopt it and have it ready for us to use. So we'll dig into it a little bit deeper in a second. We're using Drizzle Kit to basically provide that intermediary, right, to read the Drizzle package code that we're going to be writing inside of our schema.ts for each one of our apps here, along with the shared one, and basically against our URL apply the difference changes. So it doesn't overwrite everything. It just tries to apply the changes and applies it directly. There's no migration. So if there's any issues that might happen, right, push is just going to clobber over it directly based off of the differences, right? And that's the difference between the generate and migrate that I had removed earlier. But, you know, we're working in development here. There are no user data that we have to worry about. So for development speed, we're going to be going with push and just pushing all of our changes. And, you know, in the walkthrough that I have here, I'm going to make sure that everything in the schema is done correctly before we start applying any data up there. So we don't have to worry about, you know, different versions of data, any difference of, table columns, naming conventions in our schema. We don't have to worry about changing those. And so we really won't have to worry about any, pushes clobbering over existing data. So long story short, for development, perfectly fine to do push. Later on, when you have actual customers, do the generate and migrate step. But that's kind of out of scope for this particular walkthrough. The last part of this package.json, which we're spending a lot more time than I was expecting on, we are installing Neon and we are installing Drizzle, right? Neon, obviously, for our Neon database. This is the package so that we can have code in our code base to be able to tap into our Neon database. We also have Drizzle ORM here, which is the package to have access to, for this specific project, because we're using Neon Postgres, right? Postgres SQL. So it provides, again, a way for us to write SQL schemas in TypeScript code, which is incredibly helpful, obviously, for people who may or may not be as familiar with SQL. It does allow for you to write certain levels of schema or certain levels of SQL commands and extensions of schema in SQL if you're a power user. But for the most part, right, we want to keep TypeScript consistency throughout a code base. And so having Drizzle allows for us to write everything in TypeScript. Lastly, type nodes. So that's to be able to use later on. You'll see us use process.environment. So for us to be able to read and properly type our environment variables and the things that we're using, paths and file reading, for us to be able to use it correctly in TypeScript, we're going to need the types of the types package here, and .environment, which we discussed before, Drizzle Kit, which we also discussed, and then obviously TypeScript, which is base, normal. If you need to understand, TypeScript and some of the others, why they're in our package.json, again, look at our tRPC part 1, if you will. You'll have a deeper dive explanation. But this package.json explanation has gone a lot longer, but I think it's important because it provides all the foundational information that's needed for you to understand what's going into all of our databases. So cool. Now that we're finally done with that, we can actually create another piece of boilerplate here. If you'll notice, our tRPC actually had it, tsconfig.json. We'll need to add that at the DB level, so make sure that you don't add it into source by accident. So we're going to do tsconfig.json here. We're going to paste this in, and if you come from the part 1 and you were noticing that there is a difference here between these two, why is there a node here? Why is there config.ts? Well, if you remember in our package.json, we're going to be having config.ts for each of our apps along with the shared DBs. So that's what we're including here, not just the source, but the config.ts's that we're going to be adding in a second. And then obviously, if we're adding in our node types here, then we're going to add it into the compiler options to include those node types into our type checks, right? So our various compiler options. So cool. That's the only change there. And we're going to run our installation next. So some people noted that I should install first so that we don't have the error squiggly lines. I saved the install in as the last step before, but I think for readability of the code base, we should install things first. So that's what I'm going to do. So here's the first installation command here, pnpm --filter at repo/db. So we're just, even though we're doing it at the root, this will install it specifically into our repo/db. We're not installing it at the global root, right? And we want to have our Neon database and our Drizzle ORM packages. So that's what we're going to add right off the bat there. And then separately, we are going to be installing everything the same until add-d for dev dependencies. So if you remember in our package.json, let me just bring this down real quick. We separated out dependencies that we need at runtime versus dependencies that we need at the compilation step at running the Drizzle pushes, Drizzle kit pushes up to our Neon database, TypeScript to compile, and then .environment to be able to do these pushes, to be able to know which database URL we're pushing to. So there's that. Oh my gosh, let me remove all that. There we go. So we have Drizzle kit, .environment, TypeScript, and @type/nodes. So technically, if we had just done the add command here to install everything, we didn't really need to write them inside a package.json, but I was just writing it out so that we know all the different packages that we're going to need. But obviously, if we run this add command, it would just add it into the package.json anyways. But there's that. Now, we're just going to run real quick here. This pnpm-filter at repo/db type check. So we're just going to run that type check script. There's nothing in there, so should be anything that's specifically wrong, other than the fact that we don't have, we have include paths for these, but we had no inputs, right? There is no nothing inside of source, and there's nothing inside that is a config.ts file, right? So we obviously need to add those in. Until we actually have the schemas that go inside of source, and we actually have the config.ts. So yeah, that's totally expected. We're going to be adding them in right now to rectify this error. So cool. Let's start with app1. And so inside of app1, we're going to create a new file, schema.ts. And inside of here, we're just going to have a very simple schema. Bam. And so we're going to import Boolean, PG table, text, and timestamp. That's all the things that we need from Drizzle ORM. Make sure that you import it from PG core, right? There are a lot of different flavors, right? As you can see here, right? The one that we need is PG core, right? To grab the Postgres version to connect with our Postgres databases that are in Neon. Here, we are exporting app1 notes, right? Which will be the things stored in the database that are relevant specifically to the first app. Inside of here, you'll see that inside of our Postgres table, databases are split up into tables. And so we are creating a table that is labeled here, app1 notes. And we are going to be specifying our schema here each of the individual columns, right? And so we have an ID column here. And so like each entry, right? Each note, if you will, is a row. And each of these individual fields, right? Classic fields for a object in database terminology, they would be considered columns, right? So you would have a single entry and each individual field, right, of an object maps to a particular column, and that column value, right, gets governed here in our schema. So ID, if we have an ID column, it needs to be of type text, right, which corresponds to string, and we're labeling it quote unquote ID, and we're naming it the column that, and we have it as primary key, right? So that means that for each of our rows, it would be rejected if we tried to create another row in our table that has the same ID as an existing row, right? So this explicitly makes the column not null as well. So that means that ID can't be a null value, and we can't have another row with an ID. And it's the primary identifier of a note. So we would search for a note by ID. We have title here. So primary key, as it says here, implicitly makes it not null. If we were requiring a particular column, then we would need to specify not null. So we need for a note to have a title and a body, both of them of type text. Pinned is a Boolean. We can either pin the note or not. We're saying that it's not null, and by default, if we don't provide a value for it, we are saying that is default false. So unlike title and body, which we could say default to be empty string, we are explicitly telling any user who wants to add an entry into our table, a row, they need to provide some value for title and body. We're not going to automatically create one like we do for pin and set it to false. In the case of pin, we're not setting title or body to anything. So you need to explicitly set it. Created at and updated at are kind of helper columns here, and they're not null. And the default is now, which is when it is created at. And later on, when we do our operations to either update, and I guess specifically update a note, then we would update the updated at, right, column here. And obviously by default, it would match the created at, but we would obviously change the date time, the timestamp here, to be whatever time in date that we updated the note at. Now that we're done with that, we can then go on to app2, add in a new file here, schema.ts. And here we're going to add in the schema that's specific to demonstrate incidents for app2. The only difference is the body, instead of having notes here, obviously we have the severity, right? In this case, we default to low, right? And the status is open for the incident, right? We haven't closed it, so or provided a different status. And then lastly, inside of shared, we're going to create another schema.ts here. And this one's going to be a little bit more complicated. So let's have an explanation here. Our shared announcements, which is pretty similar to incidents and notes. You know, you have your ID. The unique thing is a slug here, which is basically just turning the title here into something that's friendly for the URL. So removing spaces, turning everything to lowercase, removing special characters like exclamation points, right? So it's just derived from the title. Then we have the body of an announcement created by either app1 or app2, right? So we just explicitly say that. Technically, with two apps, we could have either, a Boolean, right? True or false corresponds to 1 or 2. But in this case, right, we'll just provide a text input here to allow for us the extension opportunity if we wanted to add app 3, 4, 5, etc., right? And so this way we have, right, that shared announcements between the different apps, and we can know which app created the announcement. Also, the version. So that's just the version number. Then we have the created at and updated at field. Now, something that looks a little bit funky compared to the others, right? Because this is just a straight up object. Well, PG table takes in 3 things, right? The string here, that is the name of the table. You have this object here that essentially produces the shape of our schema. But then we also have this extra configurations that we could push in or provide. And in this case, we're saying that there is a unique ID here, right? In that basically we're saying that the slug here, when we want people to, or we want Neon to search through our database, we're saying that the slug is the unique index to which we can basically search for a particular announcement, right? And so it basically aims to speed up our searches of a specific row, in this case announcement, within our overall shared announcements table. Lastly, in case it wasn't easily apparent from unique index here, right? Obviously, every slug has to be unique, and unique index enforces that. Now, you might be wondering why we have the difference, or we have a primary key which enforces uniqueness and a unique index, and both generally are used for search, right? We will generally use in these ones search by ID, right? Because it is the unique one. So why will we have both? Well, given that this is the primary key here, it's immutable. We're not going to be changing the ID for a shared announcement. However, a title for an announcement may change. Someone may edit it. Someone, an admin in an admin console might change a particular announcement due to, let's say, an error in the announcement. So thus, the slug is not enforced in unique index to be immutable. You can keep it, or you can change it depending on your particular needs, right? And so basically, those are the primary differences why we may have both here, right? And as I was taking a real quick water break, I immediately also remembered, right, the fact that we have a primary key here, and we're not going to do it in this tutorial, but let's say we had a shared announcements, and let's say that we created another table here and called it announcement comments, right? And this thing, something like this. We can do a slug, right? Someone would just take that slug and then append it to the shared contents. We would not have a title, but instead would just be like a comment, text, comment, right? Not null. And then what we would need is a user ID, right? We don't have a user, so just assume that we had some form of user ID to connect it to a person, and then, like num upvotes, right? But we can deal with that another time for like reply. We can have replies, but I think that this gets the point across that we might have comments that are connected to a particular announcement, and we would want our tables to be able to link up together so that when I pull or I try to do a read operation and pull information from a database, and specifically read a particular announcement, well, if someone provided comments on an announcement, and my gosh, I am terrible at spelling, then we would want to collect all of the comments that are related to a particular announcement. And so how would we go about doing this? Obviously, this the slug can be the way to search for a particular comment that belongs to an announcement. So the thing that we would provide alongside this would be announcement ID, which would be of type text, right? ID, not null, and then dot references shared announcements dot ID, and then on delete to cascade. So what we're doing here is basically connecting this announcements ID to this ID in a shared announcements, whatever the row is, and to say that if it ever gets deleted, all of the comments that are attached to this shared announcements gets deleted as well. So this is a typical connection that you would make between comments that are inextricably linked to a particular announcement. And now we've created one form of the relation, and then down here we can also create a more explicit relation. So we're going to create the child side first. So export const announcements, and if I can spell announcement comments relations. So you could have multiple different relations between one table and another. So like if you had announcement comments to announcement replies, and somehow replies was a different table than a comment for whatever reason, like you wanted to have it be a thread, and the inner replies are different than the comments somehow, you might have a separate table. So you can have multiple relations. So we're going to, not use read only. We're going to call relations from Drizzle ORM. Then pass in here announcement comments, and we're going to provide in 1 as a parameter here. And that's all we're going to need. And then inside of here, we're going to provide an object announcement. Oh my God, if I could spell announcement, which will take in 1 here, pass in shared announcements, and then fields will be announcements comments dot announcement ID. So we're just providing that connection point there, and then references shared announcements dot ID. So what are we doing here? By the way, did I forget? Let's see here. Paren this. I think I need to provide. Paren to paren here. What am I missing? Right. I can't just return a object by itself. I need to put a parentheses around it, right? So that gets rid of that particular error there. And so, yeah, so you can comma this and then just add in as many other relations as you want underneath there, right? This is one side of it. So if you were to grab a particular comment and then wanted to get its parent announcement, this would be the way that you would grab that, right? And basically all this would do, right? And if I were to create the, this is the announcement comment object, right? That gets pulled. So inside of it, it would have an ID of string, slug string, I think the actual comment itself, which would be of string, and then, yada, yada, all the rest of this stuff, right? Created at, which will be a date. I'm just, obviously not writing it out the way that it should be, but you get the message, right? Another date, and then, some other pieces of information, right? The ID, or actually, that's actually important. The announcement ID, right? Which would be a type string. And, you could have user ID and upvotes, a number. But the more important thing here is that if we provided announcement here, right, then we have announcement, which would be an object, right, which would have all of these fields inside of here, right? Announcement object fields, right? So that would be ultimately what we would get if we were to query it and use relation to be able to join two rows from different tables, right, by setting up this relation. Now, on the opposite side here, right, what we would do is export const, right, announcement, shared announcement, relations, which is equal to, what was it, relations. And then we're going to pass in shared announcements, and then we're going to use many instead. And remember the paren around the object this time. And then we're going to provide announcement comments, of which this will be many. Let me see, what's the actual syntax in the documentation? It's just many of announcement comments, right? So we don't need to grab a specific ID. This was just to pull out a specific announcement. But in the case of many here, right, we're just grabbing all of the announcement comments that are connected to the shared announcement. So that's great. All seems to be working there. And right, the opposite of this would be, like ID string, yada, 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 right? And then announcement comments, which would be a list, and then, all of the announcement comments as objects, right? So that would be the shape of a shared announcement that has been joined with all of its comments via this relation. So we obviously are not doing this for this tutorial, and you saw me and my chaotic brain do a little bit of on-the-fly programming. And so, yeah, hopefully that explains things, explains why we have all of the different things that we do, a little bit of a dive into Drizzle, how it works, Postgres as well, being able to join different tables together, all that good stuff. So we have our schema all correct. I think that now we need to set up some of that connective tissue to be able to bring in the Neon side of things. So what we're going to do is we're going to close everything down. Do I need to compact this? I don't think so. So first we're going to do is at source here, we're going to create a new file. We're going to do index.ts. And inside of this index.ts file, right, here I'm just going to paste it in because why not? Right, so we're going to be importing Neon from @Neon database /serverless. We're going to pull Drizzle from Drizzle ORM /Neon -HTTP. So, there's a lot of different potential connectors for Drizzle ORM. They have one for Neon, and it's kind of weird because you're not supposed to use Neon serverless with, even though this one says Neon database /serverless, we are supposed to use Neon HTTP here. And we have a helper function here. Oh, well, let me not skip this. So we're just importing everything. So this wildcard just means that we're importing everything that's exported from schema. So if you had assumed, right, that we had kept all of this stuff, right, we had 4 exports here, right, compared to the single one for these. These 4 exports, right, and let me just make sure that I remove everything. These 4 exports would all be in shared schema, and then you would do dot to access the specific one. So it'd be shared schema dot shared announcement, right? So if I were to do, just real quick, console.log shared schema, and you could see dot, right, and then shared announcement. And that obviously returns to us the PG table, blah, 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 all that stuff, which is what we need to pass down here. But not to skip around a little bit too much, we have require environment. So this is a sanity check to make sure that we're not missing any environment variables. And really, it's not actually checking for the environment variables. It's to, it's a function to help check for it. It doesn't check for anything specific. We've got to pass it in down here. So app1 database, right? app2 database, which is why I was imploring you, right, to literally copy this into every single particular place to ensure that you have the same one. This is not the time to be typing these out by hand. You got to really make sure that you have the right one. Otherwise, you're going to get a weird error and you're going to be like, what is going on? Neon sucks. I hate it. And it's not Neon's fault. It's your fault. So, it's important to get it right. So we're passing require environment, right, to do that check in here. Otherwise, right, when we do process.environment.this, right, it could potentially be undefined, right? And we used to, in the past, I would do like, I guess I could copy this real quick and just do this. Okay, either way works. You'd have to do like process.env. This thing, right? And then this would be string or undefined, because at runtime, it's not guaranteed, obviously, that someone has provided a database URL in their environment.local, right? So if I just deleted this, right, and got rid of it, then there would be no database URL. When we run our app and it is trying to initialize this Neon object, right, and it tries to look for this, well, it could potentially be undefined. And so we need to process that. Now we can explicitly just do this, right, and assert that this exists, right? But that's kind of dangerous, and I've moved away from doing that and actually having require environment here, throwing an error, and handling it a little bit more gracefully. Now that we have the actual Neon, what do they actually call it? Returns database rows directly. Returns a async tagged template function that returns a single SQL query with low latency over HTTPS. That over HTTPS is, by the way, the reason for this. I believe, actually. I'm not 100% sure about that, but I think someone's told me that. I think, so that's probably right. We're going to take this function here and then pass it into the Drizzle function that we have here. We're also going to be passing in the schema as the second argument here. And this is the actual DB object that later on in our tRPC procedures, we're going to be using to make modifications on the database, right? And this is the way in which we can get the type so that tRPC can know the types from these schema fields. Now that we're done with all of our database related stuff, we can close this out and let's do a type check just to see if everything works, and nothing is returning an error now. So good news is, or no news is good news in this case. And so nothing returning. Sounds like we passed. So great. Awesome. So let's move on to the next step. Okay. So for the next step, we are going to push our schema up to Neon. And so actually we need to go back to our database directory here, but not actually go into source. We're just at the directory level. And remember when we provided in ts.config, right? It's at this level. It's not inside of source, right? Yeah, so it's just this. So we're going to create all three of these. So we just copy this, go up to DB, paste this in. That's 1, 2, and the last one. New file, paste, great. So very small file. All it's going to need is this. And We're going to need to change this to .local. And so, yeah, you can actually see the assertion here. So technically we could, I believe, use the same thing as in .schema.index here and do the require environment, right? But it's okay. This one's more of an internal one, so it's not going to be working at runtime of the different apps, right? Compared to index.ts, right? We're creating the Neon function here and then the Drizzle layer, right? On top of the Neon functions here to be able to provide that bridge between TypeScript and the Postgres database on Neon side. Like that, yeah, we need the database URL to be able to connect to Neon when the app is running. But for the configuration, right, we're pushing it up. Like if it breaks, right, then, you know, because of an assertion like this, you know, then it's kind of our fault, right? And you know, it's also the direct one. It's not the pooled, right? So now we're using this one down here. So it's not, I mean, obviously it's important to be able to push up our SQL or our Postgres database up to Neon, but you know, if we failed ourselves, it isn't affecting downstream customers. That's basically what I'm trying to say. So yeah, dialect Postgres SQL, we're providing the location of our schema. Where are we going to dump the outputs to this particular space here? So it's going to create a directory Drizzle slash app1. And these are the credentials that we are going to use, right? The URL, the path to the Neon database. And so obviously also config from .environment. Remember, that's the way to load environment variables. So we're basically pointing at it. And from the position in DB, right, we go up from DB. That's one // packages is another one. And thus we get to this .environment.local, which again, tempting to press on, but obviously we're doing a recording here and I don't want to leak environment variables. Note to self in the future, maybe I should add .environment.local at the end so I don't accidentally make an oopsie. But anyways, yeah, honestly, these are pretty copy pastable. So we'll just dump each of them in. The only thing that I need to do is add .local compared to my master code that I have over here. Yeah, so I think that's pretty much everything that needs to be changed. And again, right, like copy paste it from here, right? We're adding the underscore direct, but if you accidentally misspell or are terrible at spelling like me, you know, save yourself the trouble. Just copy paste this stuff. Awesome. So let's clear it all down. Now we need to open up our terminal again. And let me just squeeze everything so we can see things clearly. And this is the command. We can run it from the root by using the -- filter flag and then providing the actual repo destination at repo/db that we provided the package name for. Remember, that's why it's so important to have the right package name. We're using db : push : app-1, which, if you forget, right, was from the schema, right, this, or from our scripts, and we'll do the same for app2 and shared. So let's just collapse this real quick, collapse this, close this out. Let me just make this bigger. That much bigger? Oh my gosh. Guys, can we just render something correctly for once? There we go. Cool. So I'm going to hit enter real quick. And yeah, it's running and it's push the schema. So that was pretty easy. Obviously we can just go back and do 2, right? App2, do the same thing. And then the last one, which is app-shared. No, just shared. Cool. Awesome. And now let me pop open Neon real quick. All right, we're here in Neon again, and let me just make things a little bit bigger so we can see. So if we go into app1 DB here, and we go down to, where is it, tables, right? We'll see app1 notes, and we'll see all of the various columns of our table. Right now we don't have any rows in there, but you can see ID, title, body, pinned, all that good stuff. If we switch over to app2 DB, go to tables, after a little bit of loading, we'll see the same thing, but with severity now and status, right, for our incident tracking. And then shared DB, we should see our announcement related stuff. ID, slug, title, body, created at, version, created by app, right? So all that good stuff. It's all in here. Awesome. So now we're going to revisit our old friend tRPC and actually add in the database connectivity to do the CRUD operations into our tRPC API layer here. So the first thing that we're going to do is go into package.json and provide as a dependency, and this is, again, I'm going to keep harping on it, why naming it repo/db is so important. It obviously wouldn't work if you would provide it a different name. And then we're going to do workspace : star. Great. Then we're going to go into source here, and we're going to create a new file, init.ts. And what we're going to do in here is create a context from which we can use our databases. And so imagine the context as being a shared piece of information, a shared setup that is used across all of the different procedures that are within our tRPC implementation. So here we have a bunch of different default, not default, but pretty bog standard procedures here. We're going to create some specific procedures in order to utilize a shared context across all of these. So instead of having to set up a new database object in every single one of these procedures over and over again whenever we need to use or access the database in some way, we'll create it one time in a shared context that all of the procedures can just pull that information from. So instead of just explaining it, I think it would be better for me to show it. So first, we're going to do import init tRPC, grabbing it from @trpc/server, then importing app1 db, app2 db, shared db from @repo/db. Now, if you're wondering why we can't find anything, it's because we haven't installed. So I think it would be a great opportunity for us to install to actually get our DB to be built in relation to our tRPC package here, so that these errors are resolved. I'm always taking pieces of feedback. If you want to provide feedback on how I can be better, please do so in the comments down below. Please be nice, because I'm just trying to be as effective of a teacher as possible. So let me just hop open the terminal. Oh my gosh, let's clear that real quick and get to installing. So we're going to run pnpm install here. At the root, everything gets installed. So when we close this and reopen it, no more error. Awesome. So we're going to create now export async function. Here, if I can spell, create context, and we're going to return an object here, db, and inside of our db we'll have app1 point to app1 db, and then app2 blah blah blah, and then shared to be shared db, right? And let me just add in the semicolons. Oops, there we go. And then export type again, if I can spell, context, capital C context, to be equal to awaited return type of create context, and then const t is equal to init tRPC dot context, pass in that context type in there, dot create. There we go. And again, if I can spell export, and then export const router is equal to t dot router, and then export const public procedure to be equal to t dot procedure. Now I'm leaving this here public procedure versus a protected procedure. If you had some auth attached to the project, right, like better auth, next auth, clerk, whatever, then you could have protected procedures with tRPC, because you could provide middleware that checks if a user is authorized or not as a prerequisite for being able to utilize a particular procedure. But here we have public procedures, so technically anybody could be calling and making changes to these various DBs. There's no user checks. So I guess an upgrade to this as a next step would be to add some form of authentication. Now, I've already done that on the channel. There is I believe, better auth with Turborepo, but I'm willing to take a look at other different technologies as well. Nextauth, Clerk, Convex, I think they also do it. Actually, Neon actually has their own auth service now, so that could be its own solution. Really work within the Neon ecosystem there. Write down in the comments down below if you'd be interested in that. I started this particular walkthrough from a comment, right, that someone requested it. And so, yeah, I listen to the comments, so please provide them. And like and subscribe and all that other good stuff that YouTubers expect. So anyways, the router, we're just moving this app router. We're going to have it in a specific file. And now we're going to go up to apps, API, source, servers. And what we're going to do is remove middleware cores here. Let's remove that import here. And actually, real quick before I add it in here, we need to, inside of tRPC source index here, we should export create context taken from /init. So the reason that I'm exporting it from the index.ts is, again, in our package.json, this is the only place where we're exporting things from this index.ts. So that's why we're putting it there from index.ts here. We don't really want any external apps to have access to, the context or any of these procedures, right? So that's how we gate it. And ensure that we're only exporting the things that we want to by putting them explicitly in index.ts as needed. So inside of here now, we can grab create context from, let's see, import create, or actually, I don't need to create a separate import. I already have one up here. Create context. There we go. Cool. So that's that step complete. And now we're going to go down to tRPC again. So we can close the apps, go to tRPC inside of source. We're going to create a new directory here. We're going to call it routers. And for each one of our apps in the shared database, we're going to be creating a separate router to hold all of our procedures. So before, we used to stick all of our procedures into a single app router. We're not going to do that anymore, obviously. We're going to split things apart and hoist up various procedures to their corresponding app routers. So we're going to have app-1.ts here. And I am going to, I think it would be more expedient because this is not a learn, tRPC tutorial, right? The focus is on Neon and Drizzle and setting up Neon. I'll just go over this at a high level. We're going to need to, I believe, install Drizzle ORM into tRPC, just so it has access to these operations here. So what we're going to do is go into package.json here, grab the same version that we're using for the DB side. We're going to go over to the package.json for tRPC. We are going to paste it in and provide the comma. Then open up our trusty terminal again, pnpm install. And when we close this one, open it back up again, we're all good here. So, to go over this in particular detail, so we're grabbing descending and equal to operations that we're going to be needing from Drizzle ORM. We will be grabbing Z from Zod for type checking. We will grab app1 notes as our schema that we're going to be passing in so that, the database objects know what schema they're going to be pulling from the Neon databases. And we're going to be pulling the public procedure so that we can grab, as you can see here, CTX, which is short for context, as well as the overall router that we're going to hold all of our procedures in. And we're going to name this one app1 router, and we're going to be exporting it. And we'll see where we'll export it in a second. So the first operation that we're going to be doing is list notes. And what is the goal of this? So we're going to be selecting from app1 all of the notes, and we're going to be ordering them by descending order from when they were created at. And so we'll have the most recent one first in the list, and that's what ultimately list notes will be returning here. And so that's that one, create note. So a public procedure, again, we have no auth. So, all of them will be basically public procedures. When we have authorization, we'll add it to a context and then do like an auth check in the middleware. But also you can do things like pulling specific notes, for example, that belong to a specific person. Because when you obviously have someone who's authorized, they're going to have their user ID, and we can use that user ID to be able to grab specific notes, right, that belong to someone. But in this case, we're just grabbing all of the notes across the board for the sake of this walkthrough simplicity, right? When we create a new one here, we're using Zod object.object in order to grab the title of the note that we want to create. Then we're going to insert, based off the shape of the schema here, these values, ID, intro, or crypto.random UUID. We're just seeding a random ID for the ID field. Then we're going to have title be input of title, and then body as well. So those two things contribute to a note, and those are of a minimum size of 1, right? So that they're not null and they're not an empty string. Great. Then we have update notes, which basically just add in the ID. So we need to be able to provide a ID in order for us to be able to set, right, these values at a specific point. So here you can see we're finding the notes that match the ID that is being passed in. And we're using update explicitly, right? And with these returnings, by the way, what we're going to do is return all of the notes plus the one that has been created in this case, and the one has been updated on success, right? So obviously, if there's no success in this case, no success. I mean, if we're unsuccessful, right, then we would be returning an empty array here. right? And obviously the same for the created one up here, and then toggle pinned, right? If we have a pinned note that we want to have, then that's just an update of a single field, and in this case it's a Boolean. And then I almost forgot the delete the note, right? Where this is super important, right? Because we need to grab the right ID and then be able to delete it. And obviously there is no returning here because there's not a need to do so. Great. So let's see here. That's app1. We will go on and just paste in app2.ts inside of app2 here. We're going to paste in our router here. So the addition that we're going to have here is 2 enumerated values here: low, medium, and high, status, open, investigated, and resolved, corresponding to tickets. Everything else is pretty much the same. You have a list being the read part of CRUD. You have a create here, which again looks pretty similar. The only difference here would be severity being passed in very as a separate declaration here. So I guess technically you could just provide title at a top level and then pass it in, just like you did severity here. So either way works, so long as it is a Zod type there. You can see here that they also add in status as well. So you can pass in a title, severity, and status. Honestly, I didn't know that this existed until AI. So AI always teaches you something new. Great. Let's see. Anything else that seems interesting that I should flag? I think everything looks pretty much the same. It's just that the name is longer because it's incidents instead of notes, right? But it has the same CRUD, create, read, which in this case is listing out incidents, updating, and deleting. So CRUD is all here. And then let's just do real quick the shared one. And so let me grab that real quick to copy. And in this router, it'll be shared.ts. We'll paste this in. And the only difference is this slugify. So we're doing the replacement here to remove or to replace all lowercase values along with any special characters here. So that just basically turns a, any type of text within a title that someone might put an exclamation point, they might capitalize, they might add spaces, all that type of stuff. We're just going to get rid of all of it and condense it and provide in its stead here, as you can see, a dash line instead of the spaces and whatnot. So yeah, let's see here. Oh, so yeah, so list announcements looks the same. Most recent first. Input object here. Okay, so the enum is being set in my starter code a little bit differently, and I think the reason that I did this was to just show that these two are equivalent, right? You can put them separately up above or put them, inside of the actual Zod object. So just showing you two different ways of doing this. We're calling the slugify function here in order to provide our slug, which, as you can see here, is just passed in our input.title here. So all looks pretty reasonable there. We're providing a SQL here where we're grabbing shared announcements.version and we're adding 1 to it. So we're using a little bit of a SQL operation expression here in order to bump up the version number of an announcement. And we'll do that whenever we need to update an announcement, right? It's the same thing as like if you were writing a tweet and you had to update it and it has updated next to it, or a LinkedIn post, same difference. They'll have like a little way of letting someone know that you changed it. And in this case, right, for our announcement, It's just showing like the version number, like how many times did someone have to edit their announcement, which can cause a little bit of shame. But yeah, cool. So that's the shared one. Nothing too serious other than the slugify and the fact that we can put enums either separately. So we could do like const created by app equals enum blah, 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 blah. Or we can just provide it inline here. And the only reason that you would bump it up is if you were using it probably in multiple places. So great. Now that we have our 3 routers, we need to compile them all together. So what we're going to do real quick is go into our index.ts here, and we're going to clear out our app router here of everything, maybe except for the hello procedure, just to show that you can put a procedure in line like this, while also doing app1, pulling app1 router here from /router/app1, app2 to be app2 router, and then shared, which will be shared router. All are there. Great. So cool. Now we're going to go into our apps and actually change things to utilize our tRPC procedures. Inside of apps, app1 here, going into source and then going to app.tsx. What we're going to do is clear up some of the old things in the last step of the walkthrough, or not step, but just version that we did just to showcase tRPC in Turborepo. Now we're going to be adding a bunch of different things. We're going to keep this basic structure here the same. So I just removed everything that was the JSX tags that belong to the app, along with all of the queries that we were making. And instead now we're keeping tRPC. And we're going to be adding in some extra stuff. So first thing that we're going to do is do const, let me make sure that I'm tabbing it, const invalidate notes. And this is going to be query client. And this is taken from our props here. And if you're wondering where that's from, let's see, where is it? Main.tsx right here. So we created a singleton query client that we will share across our entire app here. And so basically we can use it within the query client provider here and pass it as a prop. So query client, and the reason that we have query client in here is to invalidate queries. And so in a second, we're going to be allowing for people to do those CRUD operations, create, read, update, and delete that we created in the tRPC router, all the procedures. And so every single time that we make some particular change to the database, right, the retrieval that we did to pull all of the notes in this case from the database, well, now since we've changed things in the database, what we currently have in our cache, the storage of those values being pulled from the database, they're now invalid, right? They're stale, if you will, which is the typical term for it, right? So the data that we're currently holding on is stale because we've made a change to the database. And so by invalidating the query there, we're basically saying, hey, the current data that we're holding within cache that TanStack query React query is currently managing for us, it's stale. So you need to go back and grab it, right? And that's the process that tracks it here in invalidate notes here, because what we're going to be passing inside of invalidate queries here is the query key for tRPC.app1.listNotes.query key. And every single time that we make some particular pull that we're going to be using within, whatever rendering that we're doing in JSX or the logic that we're going to be providing in this area here, right? We would need to update the query that we've made. And in this case, the only query that we created that pulls data from our database, the read portion, if you will, is list notes, right? If we had grabbed a specific note, right, and we called it list note, right? And let me just do it just to pretend, right? If we have two of them, then we would need to do, const invalidate query note, right? Singular note. If we happen to have that, we copy all of this, right? And then it would just be note like that, right? And we would have to remember to invalidate the notes and invalidate the note for every single time that we are pulling from the database, right? Because those are different locations in the cache that are stale and we need to update, right? But in this case, we just have one of them, const notes. And so we're making the query here, use query trpc.app1.listNotes.query options. And so you can see here, if we hover over this, right, use query results, so notes. And if I did, just to see the type, console.log notes dot, right, we have data. And if we hovered over data, you would see here ID, title, body, pinned, created at, updated at. It's also undefined because, the query could have potentially failed, right? We lose internet connectivity halfway. Some error happened on the Neon side. Their service is down for whatever reason. That's how we would be able to handle it by just having a type check, right? Like if notes, right, then we would render, or we can do if not notes, right? And then do like, console or alert, some error, right? Like, hey, we're or throw error, whatever way that you want to do error handling, right? That would be the way that we would kind of take care of that. Now we're going to create our mutations real quick. So we have create note is equal to use mutation, taking it from TanStack React Query. So before we had a hard-coded to-do list for our tRPC example. Now we actually have a database, so we can actually use mutations to change things in the database. So create notes, and what we're going to be passing inside the mutation, trpc.app1.createNote.mutation options. And then on success, usually it's a callback function, right? We can just like have that, and then we can invoke invalidate notes, right? Something like that. Now, since we only have one, we can just do it simply as, invalidate notes, right? But let's say before, right, we had the invalidate notes, then we'd have to just list them all in a row, right? And invalidate every single one. So, but we only have one, so we can just have it on success. There we go. I don't know what happened there. Invalidate notes. There we go. That's what it's supposed to look like. Then we have const update note, use mutation, trpc.app1.update note.mutation options, and then on success, invalidate notes. Okay. I am not going to type all the rest of them. There's just two more actually. So I'll just copy paste them in, right? We have toggle pin and we have delete notes there. So we have ultimately 4 of them for our CRUD operations, and we have an extra update one to be able to toggle the pinned. Then we'll add in const title, set title, all of the different states that are going to hold And we need to import use state here from React. All of the various forms that we're going to have when the user provides input, we need a place to store them. We'll store them in state. So we'll just have all of them written out here. Title, body, set body is equal to use state. And we'll set that initially to be null. And I'll just copy the rest of them because there's 3 more. So we have editing ID, set editing ID. If we're editing something, we need to know which ID or which note we're editing. And so this is where we're going to be setting it in the state. And obviously the null state is when we're not currently editing anything. Because unlike some of the others, we don't want to set an ID to be empty string because that's technically an ID that could be matching, right? So we set it to null, kind of to help also track that we're not currently editing something. But then we have the edit title and then the edit body, which is different than these ones. These ones are going to be used specifically for creating a new note. So we don't want to cross-contaminate the two. So cool. Let's see. We also have some of the form-specific functions that we're going to need to create. The first function that we'll want to add here is const handle create, and we'll be passing in e as a parameter here, react.synthetic event. It's a good super type here, used instead of the typical form event. Great, and let's see, e.prevent default, and then if not title.trim, then return. And I'll explain all of these after I've written this. Create note dot mutate, title, body, and then on success, we're going to reset the state because we don't need the old values after we've successfully created a new note. We'll just reset it back to empty string. You could technically create like a const reset state, right? And all it would have is just these two, right? And then we would just have reset state here. Totally fine. What did I do here? Oh, just return. No parentheses. Cool. Now, what does e.prevent default do? It prevents the default behavior. So when you hit a submit, it usually, with like a button press, right, or a submit action, will try to navigate a page to a particular response. And in this case, it would be refreshing the page, which would clear the state and would happen before we'd be able to trigger the mutation and thus not actually do anything. So if you don't provide e.prevent default, you're going to hit the create and then you're going to be like, well, why did nothing happen? Right? It's because you'll need to prevent that default behavior, to prevent the refresh, and to keep our state here and actually conduct the mutation, right? We're overriding the default behavior, and so we can just say prevent the default. Now, what are we doing with this conditional here? If by return, you'd probably guess that this is a conditional guard expression that's being done here, and we're doing it on the title string here. And by doing not title here, we're coercing title, usually a string, to be a Boolean by making it into a falsy value. It's one of the interesting quirks of JavaScript/TypeScript to be able to coerce things into being true or false. And so in this case for strings, right, if they are empty, then that would be considered falsy. And so this would evaluate to being not false, right, which would become true, and then you would trigger the return. Then also we have a trim here. So why are we trimming this? We're removing leading spaces. So in case someone just hit space enter, right? Technically, the string would be non-empty because the space counts as one length of the string. But by trimming, we're removing that space and thus removing that edge case of someone submitting a non-empty string, but technically there's a space in there, so it is a non-empty string. So by cleaning it up, it is now an empty string and thus turned into a falsy value. Falsy value hit with a not here will turn into true or false. So great. That'll guard it so that we don't pass in a title that is below the minimum, right? And if you remember, the minimum was of length 1. Cool. Next, after this, we'll do const start editing. So note, which is of type ID, string, title, string, body, string, and then we'll set all of our states. So editing body, we'll pass in body, note dot body. Let me do them in order, actually. Set edit ID, editing ID, to be note.id, and set editing, or just edit title to be note.title. Great. So there's that little helper function there. Then const handle save edit, which will take in an ID of type string. Then we will update note, and we'll do a mutation here. Arrow function there, mutate, and then we'll pass in ID, title to be edit title, and then body to be edit body. And then on success, we'll do set editing ID to be null. Cool. And then we'll just have some guards here, like I was mentioning earlier. Notes dot is loading. Then we'll return just loading notes. Other tutorials I've done full skeletons, but we don't need to for this one. We're just demonstrating it. And then if there happen to be an error, then we will return p error. And then we'll provide notes.error.message. Great. What happened here? Oh, I put a comma there by accident. Cool. And then for the JSX, I am just going to copy paste the whole thing in. We'll go through each part, but I don't feel like typing the whole bit in. Let's see here. ID and pinned to be... So pinned is missing. What did we do pinned to be required? So pinned is to be a required Boolean. So it'd be note pinned to be note dot pinned, but we will toggle it so it'll be not pinned. So if it's true, it'll be turned to false. If it's false, it'll be turned to true. Cool. From the top of the JSX here, we'll have a header. I mean, you've seen all of this in the demo, but just as a reminder, we'll have a form here. There's going to be 3 parts to it. 2 inputs, one being a text input, regular one. The body one will use a text area, so it's larger. For us to be able to put, a paragraph size amount of text in there. In the onChange, this is where we're going to be setting the state. Overall, the form is going to be using our handle create up here that we created. And we have a submit button here that while create note is doing its mutation, before it's hit the on success and resetted the state and added the entry to the database, right? It'll have this creating ... loading state. And so, yeah, when you hit the submit button, it calls this, and while it's waiting, it'll have the loading text. Below here, we'll have a list of all of our notes. And in each of these list tags here, we're going to have, if we're editing, a little form here to handle editing. And if not, we'll just have the note being displayed. And so, yeah, that pretty much is that. We have save and cancel. So this is a different way of executing. So instead of needing the actual form tags here, we're just putting all of these here and having the specific functions being called. Now, one of the reasons for this is if you had multiple things and you needed granular control, someone hitting enter, well, if you hit enter, you're going to trigger this create submit here. And so just because we have potentially two different forms here, this is a way to not have them conflict with each other. Now, of course, if you're reusing something like React hooks form, then this would be taken care of for you. But, you know, if we're using just basic tags here without any specific shadcn components or React hook forms components with shadcn, then we'll need to handle this ourselves. So that's pretty much the app for the app component for app 1. And what I'm just going to do is copy in the rest because they're pretty much going to be functionally the same. And I'll do the same overview for the different uses. But I think that it's better use of both of our times if I don't just type everything out. So we're going to collapse everything. Apps, app 2 here, and pop open app.tsx. In app 2 here, we're going to paste in this bit here and then do export default app here real quick. All right, from the top here, we have the two additions that are different between app 1 versus app 2 here. We have severity and status. And so for these, we're going to have a select to be able to choose between the three options, low, medium, and high. And for status, instead of editing the actual incident itself, we're going to have buttons where we can flip between investigating and resolved. And so obviously if we select something to be investigating or resolved, there's not really a reversion to go back to open. So we just need two buttons to do investigating and resolved, to select between the two and to flip between investigating to resolved, right? Open just means like the ticket has been, or the incident has been filed, right? Like a ticketing system. And once someone has viewed it, you know, it becomes sort of in progress, right? And you can't demote something that's in progress to something that's newly filed, right? It's like an unread. And, you know, sometimes in emails you might want to toggle unread, but from a ticketing perspective, probably best to be like someone's actually looked at an incident and is working on it, right? So everything else is pretty much the same. We're just swapping out notes, like list notes, to list incidents, and then we're grabbing incidents instead of notes. We only have 3 mutations because we don't have a pinned column for our incident schema. So we only have create incident, update incident, and delete incident. We're not going to be editing particular things about the incident, and so we don't need the editing states. We do need title and severity for the creation of an incident. And here we have its corresponding function. If you want, you can encapsulate this portion here into its own reset state or reset form function to just do that. But, you know, we're just going to do it in line here. And then handle status change. This is to change an incident severity or the status, right? To flip, just to flip investigation or investigated, investigating and resolved. And we're going to be able to flip between the two. And then we have our loading and error states being handled here. The difference inside of the JSX. So in our form here, we have a select here with 3 different options. We have a loading state and the base state as usual. And in our list of all the incidents, we don't have a ternary operator like we do in app 1 because we don't have a different editing state and non-editing state for our incidents. Instead, for each list item, we just have a kind of all-in-one item here where we have the title, we have the severity with a slash, and then the status, right? Open, investigating, or resolved. And then we have our two buttons here to either denote that we're investigating it or resolving it, and we change the status. And then here we can delete the incident if we no longer need it. So there's app 2. Great. And now we can move on and create a shared component that both app 1 and app 2 will use, and that's the announcement panel, right? So we have that third router with all the procedures that are going to be shared between app 1 and app 2 that affect a announcement panel that is shared across the two apps. And so we're going to go down to packages here and create a new one. So I'm going to create a new folder here. I'm going to label it UI since announcement panel is pretty much just UI. So we're going to label it that way. Inside of UI here, I'm first going to create a package.json here. And let me just copy it in real quick. It should be mostly stuff that we've seen already. Again, make sure that you name it at repo/UI. Here we have this export here, and just to explain this again, so this is dot, so this is the root. So the root is going to be this portion here, and we're adding in announcements panel to correspond with announcement panel here .tsx. Now, usually how you would import it, right, with this particular setup here is doing announcement with an E, announcement panel from at repo/UI/ this portion here. So I'll just copy it, right? Whoa, not that whole part, just the A. There we go. And that would be how the import would look, and you're grabbing it from announcement panel. Now, the way that we used to have it, right, with just dot, that would mean that we would need an index.ts. X in this case, since we're dealing with JSX. And how this would work instead is that inside of this, in order to have essentially this, right, with the dot, this is what that import from app 1 and app 2 would look like. We would have to, inside of our index.tsx, and let me just do 3 of these just to denote like the file there, and inside of here, right, we would need to import essentially the same thing, right, from /announcement panel .tsx here, right, and then we would need to then export announcement panel, right, and then do that for every single component in order for us to have this type of import. Now, personally, it could get really busy to have, 10, 20, 100 components all within UI, like if you were using shadcn UI, to have it all stuffed within the same curly braces, importing from at repo/UI. So instead, I think it's a lot cleaner to have it the way that we had initially before, like this. Right, and let me make sure I didn't Control Z too many times, but yeah, import announcement panel from at repo/UI/announcement panel, right? And here we're grabbing from explicitly named announcement panel in this specific caps here and here, and the same here for this export, right? The import up here. So we're going to create that in a second. And for dependencies, we have all of our tRPC normal stuff. We have tRPC client, TanStack React Query, all that good stuff. And then we have, for typing reasons, we need tRPC/server. And then we have our React and TypeScript related packages to resolve there. Great. And alongside package.json, we're going to need tsconfig.json. So inside of that will be this, and everything should look pretty normal, except for here we have this JSX. So because we have JSX components being rendered and used within components inside of UI for our compilation process, we're going to need to include that. All right. Our next step will be adding in a source directory here, adding a file, making sure that we name it the way that we put it in package.json, announcement panel.tsx. So great. Inside of here, we are going to add something that looks remarkably similar to app1. And let me just paste it in. And again, all of these is because we haven't installed yet. So let me just pop open our terminal here, pnpm -- filter at repo/UI install. We hit that installation. We'll have our node modules inside of here and inside of announcement panel, no more errors. So at the top here, we just have created by app. We have app1 and app2. If you added more, you're going to have to add more and quote unquote register them here to be able to use announcement panel. We have here in its props, tRPC client, query client, and created by apps. So the query tRPC client needs to be passed into the create tRPC options proxy function for us to be able to get the tRPC hook here, to be able to utilize all of our tRPC procedures and register them with the mutations and the query that we have. Right, and everything has list announcements, and the three create, update, and delete mutations. We have a remarkably similar to app1 state here, title, body, and then all of the editing states there as well. We have the form function on submit, the form function that is triggered on submit, handle create. You could, again, add this as a separate, or encapsulate it as a separate function, but we'll just leave it inline there. We have start editing here, save edit, and then handling the loading state, the error state. We have a section here. The top portion has the form, right, to be able to add in an announcement. And then having a list in each individual list item is an announcement. We have the ternary operator again, to have either the editing state for the announcement or specifically here, the rendered version. And so for this, remember, we have the quote unquote form, right? The reason that we have it is so that we don't clobber over this create form in case someone's doing it halfway again, right? So that if you were to hit submit here for another form, if someone was for some reason creating a announcement halfway, it would trigger the same submit. So instead we have it separately here to be able to edit. And then we have a button here to switch over to the editing state, along with being able to delete the announcement. So everything looks all good here. And I think we're ready to be able to use it within our apps here. So let's jump right in. And now inside of our package.json for each of our apps here, so we have app1's package.json and then app2's package.json. And we're going to add in the dependency to include our @repo/UI, right? The same thing that we did for our tRPC package to be able to utilize it within our individual apps. And then we're going to do the same thing for app2. And now that we have these updated dependencies, we're going to need to pnpm install. Great. So everything should be up to date because I think everything's built So yeah, we can go now into app.tsx for app1. And at the top here, moment of truth, import announcement panel. And you can see there, great autocomplete at repo/UI/announcement panel. Awesome. And we're going to add in the announcement panel all the way at the bottom here underneath the unordered list. Add in announcement panel, takes in 3 props, tRPC client, which will pass in tRPC client. Then we'll have, let's see. What were the other 2? I've forgotten. Query client, which is query client, and then created by app to be app-1. And this particular issue here, I think, is probably some, must be versioning type. So let me resolve this real quick. All right, so after a little bit of triage, it seemed to be because I introduced using 2 different types of TypeScript in package.jsons between this one, 5.9.3. In this one, we have 5.8 as a range, right? And that is obviously different. Then inside of here, we have 6.0.3. So that's the mismatch here, where we have this difference between 5.9.3 and 6.0.3. So this is why this is super important to have it all along the same lines. So what I could do is just, go back in and change every single one of these to be a particular TypeScript version, or I can go back to the root package.json here, and inside of this object here, we're just going to add underneath here pnpm, and then we're going to have an override. We're going to have TypeScript, and it's going to be 5.9.3 explicitly. And then we're going to change the dev dependency in here to be the lesser one. Great. And so that's going to be forcing every single package in the workspace to use 5.9.3. And that's going to clobber this. Okay, and so we're going to need to remove our node modules, rm-rf node modules, pnpm lock.yaml here, and then after that, then do pnpm install, and hopefully that will resolve our issue. There we go. No more of that error. But we do have a different thing. What is the different thing? Cannot find module these things. So I was wildly confused about that error, but just relaunched VS Code. And yeah, great. Thanks IntelliSense for giving me another heart attack. Okay, good. So we have announcement panel all set in here. So all we need to do is replicate it within app2. So let's open up app.tsx here. Let's grab the announcement panel and stick it in here. Now, let's see here. We probably cannot import it. Oh, we can. There we go. Great. And then we change this to 2. Bang. And everything looks good here. Yeah. Awesome. Great. We have a couple more house cleaning things until we're ready to approach the demo. And so here we're going to go into API and make sure that we're able to set up so that our server is able to connect to both of our apps beyond just having the context here, along with being able to load the environment variables at runtime. So what we're going to do real quick is actually create a new file, and we're going to name it environment.ts. And so this is how we're going to load the files. So first we're going to do is import config from .environment, which means that we're going to have to install it in a second. There's the error. I was worried there. Or I thought I was going to get away with it for a second there. Great. I guess VS Code long-running session. It's freaking out a little bit. I don't blame it. File URL to path from node :URL, and then config path file URL to path new URL, which will be .environment.local. And then we're also going to pass in import.meta.url. Great. So that's all we need from environment.ts. Make sure that you import it at the top. It needs to happen before every other import. So we're going to import ./environment.ts. Sorry, that's just .environment. We don't need the TS. And then for the rest of this, we're going to need to add back in our CORS middleware that we had removed earlier, but we'll provide it in a different way. So we're going to do CORS here, and then let me just import it. I guess I didn't need to remove the import before. CORS from CORS. And we'll have that resolved in a second via install. And then I need parentheses. Whoops. Parentheses, semicolon, origin to be a list here. We have HTTP :// localhost 573, which we've set. And then the other one is 574. So our API will be at port 2022, and the two apps will be at 73 and 74, respectively. Great. Whoops, comma, not a dot there. And let me just run real quick over to the package.json here. And let me just add in real quick. Or we'll just do, where is it? pnpm-filter at repo/API add .environment. So great. Let's see, .environment has now been added. So environment.ts is good. And then CORS, for some reason, is not good. I believe it's because I need to put it in quotes. There we go. So there's that issue resolved. And so now that we have all of this set up here, we should be good. Let me just close this out real quick and restart it. I don't know why I have a separate bash here. I just killed that other one so we had more room. I don't know why that one popped up. VS Code's being weird. So now we're going to do pnpm dev, which you'll see we have our two apps running at 5173. So if I control click real quick, we have here, we're just proving the demo, right? We'll do a polish pass after to clean things up, or I'll just use AI to clean things up and make things look nice to what you have seen in the demo, or in the intro, right? The intro demo, because at this point I have no clue what the app is going to do, because I haven't gotten that far yet. I just wanted to make sure that this worked. And let's just do 5174. Great. Now let me see. Can I do this? There we go. So now we have them side by side. We can remove these. Remove the notification there. So yeah, if we're going to add in real quick a note. So we're going to say hello from app 1. Hello world A1. Create note. And we can see there's our nice note there. And let's just do the same for incident title. Help from app 2. And this is a high priority incident. And you can see that it is created successfully. If we hit refresh, it's still there because it's persistent in the database server, right? And right now it's open. If I hit investigate, it is now investigating. And then I can flip it over to resolve, back and forth. And then on this side, I can pin it, add a little pin icon there. I can also unpin it. And then I can edit it, right? Hello from app 1 edited. If I save this, right, you'll see there. Now, shared announcements. That means that it's going to pop up in the 2. All right. And so we're going to do announcement. For some reason, I really struggled to write that. From app 1. Hello from app 1 test. Post the announcement here. And then on this side, if we refresh, we'll see the same thing. So we don't have a WebSocket created so that app2 can detect that something has been changed in the database. It'll only show up on refresh, but it is pretty cool that on refresh it does show up. So let's just create here, help from app2, please help me post announcement. So we have that most recent announcement there. And see that we don't have anything yet until we refresh. And bam, we have hello from app2. So we have shared announcements. So these two databases are shared between these two apps, and they're showing. Wonderful. So real quick, I just hate how these look. So for the final demo, I'm just going to pretty these up really quick. So we're going to have a little bit of fun. We're going to close this. And what I'm going to do is just run Claude here for a second. And just say, can you take a design pass of both app demos? They're pretty bare. Make them look nicer for a demo. Great. So we're just going to run this real quick, and we'll evaluate what AI has done. And, be ready for the conclusion of this with a polished application. And by the way, right, our entries into the database are saved. We haven't deleted anything. So once we get our polished websites back, I'll go in and start removing stuff. So let's wait for this to finish, and I'll be right back. All right, it's finished. Moment of truth. Let's open this and this. A little nice loading state there. Let me just split these. And here we go. Looks nice. Somewhat. Yeah. I can agree with this. Looks nice. Look at that. Yeah. I like it. So, we're probably gonna get to recording the demo in a second, but just to cap it all off, I need to obviously clean everything up. So we're going to delete everything. No notes. Great. No announcements. And yeah, we should be able to delete from 2 here. Refresh. It's gone. We're going to delete on this side. Refresh. Not here. Refresh. Not there. Great. So this one's clean. This one, we just have one more. And bam, all set. Nice. So that concludes this video. You can see that we now have 2 separate apps on 2 separate URLs being able to interact with their own databases and each other's, a shared one, right, that they can influence each other. Now, there are some upgrades that might be needed. So again, if you're interested in upgrades, put them in the comments down below. I feel like WebSockets, so that an update to one can sync with another, that requires having probably a node backend, right, and being able to run that. Maybe that's a tutorial to utilize Railway to be able to set up a basic infrastructure there, or oh gosh, I forget what their Live Blocks, I believe, was another tool that we could use. Like, let me know down below if you'd be interested in that, and any other upgrades that you think that you would want to learn more about, right? I could see authorization being a thing that's important, right? Being able to hide notes for certain types of people, using resend to send emails. So if you made it this far, that'll be your reward to be able to know about the fact that you can provide suggestions in the comments down below. And like this video that was spawned from a user suggestion, I'll be able to do it down, just gather the comments down below and work from there. So until next time, everyone, look out for your comments, and we'll be jumping into the next walkthrough. Goodbye.